Okay, so if we accept the fact that the Taylor series works every single time, then f of x, so the Polynomial approximation for the function of x is equal to the nth derivative of function of f multiplied by x minus the point you want to approximate to the power of n factorial. So if we try to approximate a function of sine of x, so if we say f of x equal to sine of x, the first derivative of sine of x is equal to cos of x, and if we keep doing this, we'll find out it will eventually turn back in a cycle. So f3 equals to negative cos of x, and then the fourth derivative equals to sine of x. So now we are back into a cycle, and we can keep doing this. So that means if we are trying to approximate the function of sine of x at point A, so A equals to 0. So if we try to approximate the function of sine of x at point 0, and if we substitute into the Taylor series, we will get the first derivative of sine 0 is 0, plus the second one, the first derivative of cos x, subbing 0, we got 1. So, but that's 0, so we can forget about A. So that's 1 times x to the power of 2 over 2 factorial. Oh, is it? No, it's not. That's first derivative, so that's just x. Yep, and then plus the third derivative, so sine x goes to 0, so forget about it. And then, so that becomes a minus x to the power of 3, because that's the third derivative, so now we have to do x to the power of 3 over 3 factorial. And then follow this pattern, that would be the fifth derivative. Yeah, that's the fourth derivative, so that goes to 0. Don't care about it. That's the fifth one, so that's a positive. So now we have x to the power of 5 over 5 factorial, and then the pattern continues. So if we simplify this, now we have f of x equals to sine of x is equals to x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial minus ... And then we can, another way of writing sine will be a series from, let's start with n equals to 1, it goes all the way to infinity, and then we have negative 1n, 2n, so we can oscillate this, and 2n, okay, let's start from 0, so that's 2n minus 1 of x, so that's a 3, so that's, so when x equals to 1, have to be 3 plus 1 over 2n plus 1, because the power and the factorial is the same. So that's another way to write sine. Yay! All right, next one.